Yeah, there are so many categories of different AI. I'm going to try and break it all down, but also there's so many. I'm not going to be able to talk about them. I'll just highlight the ones I like best. First, let's talk about the big labels. Artificial intelligence is the broad label for any computing system that tries to approximate intelligent behavior. So like the very basic ones like Siri on your phone. This is my basic attempt at drawing a phone. Good luck for the rest of this video. I'm going to stop drawing. I lied, I drew again. But stuff like the chessbots, those are also artificial intelligence. Within that, we have a field called machine learning. This is where algorithms can change themselves in order to better suit the data they're being shown. So for example, if I have a model that's a straight line and it can change the parameters and then I show it a bunch of data, it's able to then perform linear regression to perform a best fit of that data. In other words, the machine has learned what this best fit is. Now within that we have deep learning, which use neural networks to be shown a load of data and then alter themselves for specific outcomes. So maybe I have a model where I showed a load of photos of dogs and cats and I want it to learn to be able to categorize them into dogs and cats. And then within deep learning, we have generative AI, which is all the stuff like large language models and AI art generators, stuff like that. So these days we have a habit of saying AI and just meaning generative AI, but it is important to remember it includes a whole ass field of computer science. And sorry to any computer scientists, I have simplified this an awful lot. So let's talk about a couple of different deep learning and generative AI architectures. So the architecture is just the way that the model is set up, and typically this is done to perform a specific type of task. The most basic of these is a neural network. Basically we have these nodes here, these are just numbers, and then they have these connecting lines that the computer can change the strength of the left to the right. So if I have a 1 here and this red line means a 2, then a 1 here will give a contribution of 2 to this node. Now this is really useful because it can be done a lot with just linear algebra, but this is the very basic form of machine learning. The next one we have is convolution nets. Basically we have the machine learning a kernel which goes across this image and then translates to some other dimensional space. The maths behind this one is a little bit complicated, but don't worry about it. A generative one you've probably not heard of is normalizing flows. What they can do is take a latent distribution, so that's like this one here where we have a Gaussian, which is very normal, apply a couple of transformations and make something that's really complicated. And the way we train this is really cool. We start with the complicated thing and we train the network to go backwards to the normal distribution, but all of these transformations are reversible. So if we train it to go one way, then it can go the other, which is really cool. Oh, I just saw the time. I spent so long talking about this. Let me know if you want to hear more about the weird and wonderful world of the many, many architectures of AI. And if I have more time, maybe I'll be able to explain them. Anyway, I hope you have a lovely day. Okay, bye.